Hello, this is the continuation of part 3 of the video series on solving triangles. In this video, we are going to look at trigonometric ratio of common angles, but the answer will be in short form. This is quite useful, especially in JAMB in previous years, where you are not allowed to use calculator. But even in WAEC, you might be asked to leave your answer in short form. So how do you do this? We are going to derive the trigonometric ratios of angles like 60 degrees, the common ones, 30 degrees, and 45 degrees. So let's look at that of 60 and 30. So to do this, we look at an equilateral triangle of side 2 units. So equilateral triangle, that means all angles are 60 degrees, 60, 60, and all sides are 2 units. So if I draw a bisector, let me label this as ABC. So if I bisect the angle A, so by bisect, I mean divide the angle into 2 equal halves. So the bisector will be at right angle to this side, BC. So this will be 90 degrees and this will be 30 degrees, okay? Now I'm looking at, if this point is D. Now I'm looking at triangle ABD or ACD. Now, how do I get the height of the triangle? So I can, because I've bisected this side, BC, so this BD will be 1 and this will be 1 because divided 2 by 1. Now I have this triangle now. So let me write out the half of the triangle. So this is right angle. This is 2, 1, this is 60 degrees. So A, B, and D. So I'm just using half of this triangle. Now this should be 30 degrees. Now how do I get this? The height. So I can get that using Pythagoras theorem that we've learned before. The square of the hypotenuse, which is this, will be equal to the sum of squares of the other 2 sides. So we have 4 equals a squared plus 1, and a squared will be 4 minus 1. So it means h squared will be 3, and h will be what? 3. Now I know h. I know this side as 3. Now I can write the sine, cosine, and tangent for the angles 30 and 60. So what will sine 30 give us? Sine 30, it is popular. Sine 30 will be opposite. So the side that is facing angle 30 is 1. That's opposite 1 over the hypotenuse, which is 2. So sine 30 is half. You know that. That's very common. Then what is cos 30? Cos 30 degrees will be adjacent. So the adjacent to this angle will be √3 because 1 is opposite and this is hypotenuse. So √3 over the hypotenuse 2. Remember, for cos, we are using car here. And for sine, we use so here. And for tan, we are using toa. So that's really tan 30 will be equal to, then opposite to that angle is 1, then the adjacent is √3. So which means sine 30 is 1 over 2, cos 30 is √3 over 2, and tan 30 degrees is 1 over √3. Let's go to 60. Sine 60 degrees will be, then now I'm using this angle. The opposite to this angle 60 will be √3, and the adjacent will be 1. So sine 60 degrees, so that's opposite √3 over the hypotenuse 2. Then cos 60 degrees will be adjacent to this angle will be 1, and hypotenuse is 2. And tan of that, tan 60 will be opposite, which is root 3 over adjacent. And the adjacent is what? 1. So root 3 over 1 is root 3. So it means sine 60 is root 3 over 2. Cos 60 is 1 over 2. And tan 60 will be root 3 over 1. So you can see this is true because tan theta is sine theta over cos theta. We can verify that. So sine 60 is root 3 over 2. That means root 3, if I'm doing for 60, so tan 60 will be sine 60 over cos 60. Like, I just want to quickly verify this. So tan 60 degrees will be, what is sine 60? Root 3 over 2, then divided by sine cos 60, which is half. So we've changed the sign to multiplication to 3 over 2 times 2 over 1. And that cancels, and that gives you root 3. So that's, you can see that that's the same as that. So that's for 60 and 30 degrees. So anytime you have to leave your answer in short form, if you remember this triangle, then you can easily derive or determine the sine and cosine of angle 30 and 60 degrees. Now for 45 degrees, so we are going to use right angle isosceles triangle. So by that, I mean a triangle that has right angle and the other sides are equal. So these two sides are equal. And so by implication, this will be 45 and this will be 45 degrees. So because these two sides are equal, they are 1 unit. These two sides are 1 unit in this triangle, and I can calculate the hypotenuse here. I call this x. So if I want to, if I use Pythagoras theorem, I can calculate the hypotenuse. So x squared, which is the square of the hypotenuse, will be equal to sum of squares of the other two sides. So x squared will be 1 plus 1. Then it means x squared will be 2, and x will be root 2. Now I know the hypotenuse as root 2. So I can use that to get sine 45 degrees, cos 45 degrees, and tan 45 degrees. So sine 45 degrees will be equal to opposite. So if I use any of these two angles, opposite is 1 over hypotenuse of 2. Then cos 45 degrees will be adjacent. So adjacent to this angle will be 1. And hypotenuse is root 2. So you can see sine 45 and cos 45 is the same. They're the same, and tan 45 degrees will be opposite. What is opposite to this angle? 1 adjacent to this angle is 1. So 1 over 1, which is 1. So we can verify that quickly, just the way we verified tan 60 by checking that tan 45 degrees was sine 45 degrees over cos 45 degrees. And that's 1 over root 2 divided by 1 over root 2. And you can see that clearly that will give us 1. So this will cancel 1. So 1 times 1, everything will give you 1. So that's how you get the sine, cosine, and tangent of angle 30, 60, and 45 degrees. So if you are doing your calculation and you have to leave the answer in short form, if you are working with trigonometric ratios of acute angles, and you have to leave your answers in short form, you apply these. Thank you, and see you in the next video. Bye-bye.